Hello children, welcome to the My Dream. Today we are discussing the mechanical properties of solid. So we are talking about the mechanical properties of solid. As you know about the rigid solid, hello children, welcome to the My Dream. Today we are discussing the mechanical properties of solids. Yes, the material having a definite shape and volume. Whatever the material is given to you or you are having, but it have the definite shape and volume are known as solids, or you can say rigid body. Yes, in solids, atom and molecules, atoms and molecules are arranged in such a way that each molecule is acted upon the forces atom and the molecules are arranged in such a way that each molecule is acted upon the forces due to the neighboring molecule. Atom and the molecules are arranged in such a way that each molecule is acted upon forces due to their neighbor molecules. This type of forces, this type of forces is known as intermolecular. I am talking about intermolecular forces. Yes, the material, those who are having a definite shape and volume, that is called solids or rigid body. And in solids, atoms and the molecules are arranged in such a way that each molecule is acted upon forces due to their neighboring molecule. Understand? Now we are talking about elasticity. Elasticity. When a deforming force is applied on an object, when a deforming force is applied on an object, obviously there is the change in their configuration. When a deforming force is applied on an object, obviously there is a change in their configuration, or you can say shape and size. As we remove the deforming force, forces, if the object will acquire their actual shape and size. This phenomena is known as elasticity. As you remove the deforming force, if the object will acquire their actual configuration, actual shape and size, this phenomena is known as elasticity. And that object is called elastic object. Yes. Now I am talking about the plasticity. Yes, as we remove the deforming force, if the object will not acquire the actual configuration, when a deforming force is applied on an object, obviously there is a change in their shape and size. As we remove the deforming force, if the object will not acquire the actual configuration, this phenomena is known as elasticity. Now, I am talking about the stress. Before we discuss the stress, I want to tell to you, when a deforming force is applied on an object, when a deforming force is applied on an object, a restoring force developed inside the body. When a deforming force is applied on an object, then a restoring force is developed inside the body. Then, yes, now we are talking about stress. The restoring force per unit area of a body. Restoring force per unit area of a body is called stress. Yes. As the deforming force is applied on an object, then the restoring force developed inside the body. Now we are talking about the stress. The restoring force per unit area of a body is called stress. The restoring force is equal and opposite to the deforming force. The restoring force, the magnitude of the restoring force is equal and opposite to the deforming. So stress is also defined as the deforming force per unit area of a body is called stress. Either you can say the restoring force per unit area of a body, or you can say deforming force per unit area of a body, that is called stress. And types of stress. First of all, we are talking about the normal stress. What do you mean by the normal stress? The restoring force, force per unit area so difference, what is the difference? The restoring force per unit area perpendicular to the surface of a body, The restoring force per unit area perpendicular to the surface, that is called normal. Stress is also defined as external applied force, or you can say deforming force area of the body, So the restoring force per unit area perpendicular to the surface, that is called normal stress. And normal stress are of two types. One of them is tensile stress. Another one is the compressive stress. Both of them are also known as longitudinal stress. It means there is a linear expansion. Now, what do you mean by the tensile stress and compressive? When yes, if there is a change, in the length of a rod. If there is a change in the length of the rod, then the two possibilities are there. Two possibilities are: first, the first one, when the two equal and opposite force, when the two equal and opposite forces applied on a body at the ends of the rod. At the ends of the rod. Suppose this is a body of length L, and you are providing the force like it means there is a change, there is an increase in length. And second one is, the second is when the two equal and opposite, when the two equal and opposite forces applied on a body, on the ends of a rod. So this is on the end of a rod. This is at the ends of the rod. Yes. This is a length L. Now, you are providing the force like this. So it will become L minus delta. So there is a decrease in length, and this type of stress is known as compressive stress. Whereas this type of stress is known as tensile stress. Generally, you can say longitudinal stress, or you can write down like this: tensile stress, compressive stress, that is a longitudinal stress. So at the end of the rod and on the ends of the rod, this is the difference. Now, let us talk about the strain. Strain is defined as it is the ratio of the change in configuration to the ratio of the change in configuration to the original configuration. That is the strain. Types of strain: longitudinal strain. Longitudinal strain is defined as it is the ratio of the change in length upon origin. It is the ratio of the change in length to the original length, and this is volumetric strain. Volumetric strain. Longitudinal strain applicable as solids. Volumetric, if you are having fluid in which an object is dipped, then there is a change in volume to the origin. Okay? And this is shear strain. शेयरिंग बोल सकते हो आप, शेयरिंग. This is delta x, delta x. This is L. This one is theta. So tan theta is equal to delta x by L. Since angles are very small, so it can be written down like this. tangentially work कर रहा है. You are applying the force like this. Next. Now, so strain is defined as it is the ratio of the change in configuration to the original configuration. If you are talking about the longitudinal strain, you are having a thin rod. You are providing a load. Because of that load, there is a change in length. Volumetric strain, if we are considering the fluid in which an object is placed. Shearing strain, this is shearing strain. My dear, it works tangentially. Now we are talking about the Young's modulus. Young's modulus, it is related with a line segment. The Young's modulus is defined as it is the ratio of the tensile stress to the longitudinal strain. Why we are using the tensile? Because of the load, there is an increase in length. In case of increase in length, that is given by tensile stress, not the compressive. So y is equals to, that is tensile stress to the longitudinal lambdoid. Longitudinal strain, force upon area, change in length upon original length. If you are considering a string like this, having the load, this is the actual length, this is the area of cross section, this is the weight. Because of the weight, there is a change in length. So that is given by FL divided by delta L into A. In place of F, you can write down M into G. That is beta that is delta L into pi r square. Pi r square, this is pi r square. So MGL pi r square into delta. This is the Young's modulus. ML minus 1, ML minus 1, ML minus 1, T minus 2 is the dimension of pressure. Young's modulus. Bulk modulus. Modulus of rigidity. Modulus of elasticity. Modulus of elasticity. Stress. Energy density. Energy density. They all have the dimension. Yes, unit Newton per meter square. Unit of all. Now we are talking about the bulk modulus. Bulk modulus. Bulk modulus is defined as it is the ratio of the volumetric stress. As you know, I think so, the stress force upon area, pressure force upon area. Stress acts in 2 dimensions, whereas pressure acts in 3 dimensions. So that's why we are using volumetric stress. That is the pressure to the volumetric stress. So bulk modulus is represented by B or K, that is pressure, this is change in volume on original volume, here negative sign. As the pressure increases, volume decreases and vice versa. Yes. Now, it can be written down it can be written down like this also, PV divided by delta. This is the bulk modulus. Bulk means volume. Now, variation of density, variation of density with pressure. Now we are talking about the variation of density with pressure. How it is affected? How it is affected? Yes. As we know, density is equal to mass oblique volume. Mass remains same. So density is inversely proportional to this. Density rho dash divided by this, that is V dash divided by V. And V dash, that is V minus delta V. So rho dash divided by rho V minus delta V. In place of V dash, you can write on this. So V common, V minus delta V by V, which is given by 1 minus delta V by V. As we know, got it? As we know, this is minus P by delta V by V. So delta V by V gives minus P by K. So in place of this, you can write down rho dash by rho 1 minus minus plus P by K. As P increases, density increases. As P increases, density increases. This is P. So this is the variation of density with pressure. Now, according to Hooke's law, stress is directly proportional to strain. If you want to draw the graph, this is the stress, this is from the origin up to this level, stress is directly proportional to strain. As we replace the proportional sign, stress upon strain gives a constant, and that constant is known as modulus of elasticity. Modulus of elasticity. After that, the graph will be like this. This is the maximum limit to extend. This is a breaking point or fracturing. From O to A, it follows the, okay. After that, we are talking about the modulus of rigidity. Modulus of rigidity is given by tangential stress to the shearing stress. That is F upon A. This is theta. As I discussed before, yes, this one, delta X. So, in place of theta, you can write down delta X by L. Since angles are very small, so delta X by L, so theta is equals to delta X by L. That is the modulus of rigidity. Now I am talking about the elastic after effect. Elastic after effect. The delay in regaining the actual configuration of a material Obviously, that must be elastic. The delay in regaining their actual configuration, that is called elastic after effect. Another one is elastic fatigue. What do you mean by the elastic fatigue? What do you mean by the elastic after effect? The delay in regaining their actual configuration. As you remove the deforming forces, at that instant that will not acquire the actual shape and size. And this is the loss of strength. The loss of strength of a material due to the repeated strain. As you are stretching the objects like this so many times, then it will lose their behavior of elasticity. Elasticity. Next. Now, this is the last topic of mechanical properties of solid. Energy stored in a stretched string energy stored in stress. As we know, stress is equals to force upon area. Strain is equals to change in length upon area. When we are considering the string, obviously you know the Young's modulus, that is force upon area, change in length upon original length, from which you will get the value of force. That is YAL by L. As the string is stretched due to the weight, due to the load, due to the force, the work done in stretching, a small length, that is delta L. So delta W is equals to force into displacement, that is delta L, and the limit is 0 to L. So in place of this, you can write on YAL into delta L. This is delta W. So delta W will become YA by L, L delta L. So it will W is equals to YA by L, L square minus 0 by 2. So which can be written on YAL by L into L. That is, this is the stretching force. This is the stretching force, YAL, stretching force into extension. Stretching force into extension. Yes. If you want to know the work done per unit volume, is equal to potential energy. इस फॉर्म में एनर्जी स्टोरेज पोटेंशियल एनर्जी पर यूनिट. That is half YAL by L into L per unit volume, that is volume. So YAL square, that is volume, is area into length. Area into length. Y small l square by capital L, which is Y into strain square. So the potential energy stored is given by potential energy stored per unit volume is given by half Y into strain square. In place of Y, you can write down stress upon strain. That is which gives half stress into strain. This is the potential energy stored per unit volume. Yes, this is all about the introduction of mechanical properties of solids. In the next session, we will discuss the problem based on mechanical properties of solids, which has been asked in previous years. So, okay children.